You've probably wondered what's the best path to start learning machine learning, and today we're going to talk about why it is actually much simpler than you might think. So, we'll go over the basic step for starting to learn machine learning and start building your first, let's say, computer program that learns to program itself. So, the first thing that I want to talk about is that LLMs are very popular right now, but the reality is that they're a tiny fragment of the ML industry. So, I would say that AI and the machine learning industry became very popular in the last couple of years, obviously because of tools like ChatGPT. But the reality is that it is a tiny fragment when it comes to all of the things that you can learn how to do inside of the ML industry. So, my advice to you would be to, instead of picking LLMs, you can choose a less popular subfield that hasn't been explored as much lately. And the reason for this is, first of all, you'll have less competition if you want to end up working in the field down the line. I also think that it is much more interesting to explore different ideas within this field, so different subfield, instead of just sticking to one thing. And finally, I also think that if you're watching this like me, maybe you're getting quote unquote tired of hearing about LLMs all of the time. So it is nice to escape for a little bit and try something new, just explore different ideas. So, three things that I thought about while I was writing these slides is, first of all, reinforced learning. Obviously, not something that is necessarily outside of the world of LLMs, but what I mean here is things like mini grid. So, you have a grid and you want to teach your model how to take actions inside of that environment. You can have something like a maze and you teach the model how to complete the maze in the best way possible, the most efficient way possible. And you also have things like small games that you can teach your model how to play. To accomplish this, you can use again stuff like mini grid. You can consider that a small game, or more powerful tools like Perflib. Then we also have computer vision. This is a much harder subfield within ML, but you can still try to tackle it and explore it. And finally, also another one that is very hard, which is robotics. But before we continue with this video, I want to invite you to join the Tech with Tourist Inner Circle, a private group for programmers that want to grow their skills and explore new and interesting topics within programming. When you join, you'll get access to weekly group calls for members only, where we'll do everything from teaching classes, have open-ended discussions, and explore new and fun projects. When you join, you'll also get access to a private Discord server where you'll be able to chat with other members and with me. And last but not least, you'll have access to exclusive pre-recorded courses on a range of different topics such as front-end development, back-end development, machine learning, tooling, and much more. To join, go to techwithtourist.com/IC. That's techwithtourist.com/IC. Tools that you need to get started, contrary to what most people might tell you, are actually just two different tools: Python, the language, and PyTorch. You don't need anything else. If you have, obviously, assuming you have a computer with a CPU, you probably don't even need a GPU to get started if you're not like training something very big. If you have, it is a plus. In my case, I have, so I use PyTorch with the MPS backend. If you have NVIDIA CUDA, I'm not really sure other tools like MLX, is because it is the most popular, used by most of implemented in production the most. So I think much better to get started with PyTorch. Because of that, you have a lot more examples related to ML are mostly built with PyTorch. And later, if you want, you can start exploring other array frameworks and stuff like that down the line if you prefer. But you don't need stuff like a notebook, like a Collab notebook. You do not need that, and you don't need any kind of like fancy tool to necessarily like visualize the data and all of that stuff. Those are secondary things. The minimum that you need to get started is Python and PyTorch, and you're good to go. You open your editor, start writing code, you build something, and then you run it in your terminal, and you are good to go that way. Now, one question that is also commonly asked is, do you need to know math to get started in ML? And the answer is yes and no. Here's exactly what I mean by this. Math can help you in what I would consider like the two biggest things that it gives you an advantage in. First of all, it helps you debug problems. If the problem that you are having when it comes to your model is not a technical one, like some sort of like integration with a GPU, like configuration of PyTorch, those kinds of things, it usually means that the problem comes from the implementation itself. So like how you arrange the modules, how you're doing all of the calculations and stuff like that. And here, knowing math can help you debug things faster and see exactly where the problem is, because you can look at the, let's say, the results, the loss rate, and then try to much quickly understand exactly why the loss rate behaving in a certain way and how that translates to the math inside of the model. But the reality is that, and this ties to the second point, it also helps you when you want to come up with a unique and novel technique, but otherwise it is usually not going to be very necessary, because a lot of the like architectures, a lot of the techniques, a lot of the implementations that you're going to come across, especially when you get started, are going to be things that have already been discovered by other researchers, and they are already stuff that can be thought of as like things that are well established within the industry. Most researchers do things that way, so you just need to sort of understand up to the point of knowing why it is done, why something is done the way it is done, but you don't necessarily would need to have like the math ability to come up with that on your own from scratch. So if you think about like the transformer architecture, within that like multi-headed attention, you can think about UNet. All those architectures are stuff that again were already created and invented by someone else, and you just need to learn enough to be able to implement them, and you don't need to like reinvent the wheel. And for those reasons, I think that math, while very good to know because it helps you like have that extra advantage, it is not necessarily, especially when getting started within this field. So what I would recommend you do, and this is probably counter to what a lot of like a traditional path within machine learning is I would just recommend that you pick a very small task that you want to accomplish, like a goal for a model that you want like the model to be able to do, and then just figure out how to solve. So I gave here an example, like teach a model how to predict the next position given an action. So if you have like a 10 by 10 maze, you put like an agent in a certain like position, and then you generate a set of actions and the next position within the maze where the agent will be. So if the agent moves forward or does like a turns to the right, so its direction gets turned, and then you just want to teach the model how to predict the next like position given an action. And this is something very simple. Again, that's why I said at the start also that if you start with the LLMs, you're going to have all of this complexity of like the transformer architecture and like tokenizing stuff, and like a lot of complexity that comes with knowing how to do all of the things necessary to build a LLM from scratch. And something like this, a very basic 10 by 10 grid with a set of actions, is something that is much more doable, and you'll start understanding what everything means within PyTorch. You'll start understanding like what the shapes mean, what certain kinds of functions like transpose, permute. You'll start understanding how to do certain kinds of like calculations like matmul, so mate multiplication, and how to use basically all of the internals of PyTorch to accomplish something that you want to accomplish with such a simple like end goal, instead of just starting with something very complex and doing things that way. And I think this is a much simpler path, especially if you don't have again that science or math background, which is probably what currently most of the researchers have. And yeah, I think it is a very viable path to do it this way, where you start by building things and sort of gradually build your knowledge up in that way. So yeah, this is it. I hope this video was helpful to you. Let me know what you think in the comments down below, and I'll see you on the next one.